also. Just a quick recap. We have imported all the necessary packages, and then we have ingested this data into a data frame called SDF. And then we explored how many number of rows are there, how many number of columns are there in this data set, housing data set. And the objective of this one is we want to predict the housing price. Okay, here these four variables are features, independent features. The price is the housing price. So this is the dependent variable. Okay. So what we are going to do is we are going to split this 148 data records into training and test data set with 75-25 ratio. But before that, we want to understand which independent variables or the features are correlating with my dependent variable. Why should I know that? So those features, in the case of linear regression, the independent variables must correlate with your dependent variable. Those independent variables that do not correlate well with your target variable, in this case, housing price, those variables are not at all helpful in terms of predicting your housing price. Okay, next we explored how many number of records and how many columns are there, and then we plotted this one. So in one shot, using parplot function, we can see all the independent variables, how well it correlates with the price. We can see that park and size, these two are not correlated well. Okay, and so there is an issue with the package here, ignorable. So better we can rely on this one. This is your heat chart, heat map. And how to interpret this one, you can see in the x-axis size and all the independent features, you can see it, including the price also, the dependent variable. And you need to look at, to compare the size with price and UDS with price and park with price and MIC with price. Obviously, when you compare with price, it will be 1 only. The correlated value is 1. Okay, usually we don't compare, the same variable with the same variable. So size and price, if you see here, 0.0, 0.8, any value which is closer to 1, which means it is highly correlated. Hence, if you include size in your machine learning model to predict the housing price, it makes sense. And UDS is also somewhat closer to 0.25660, right? So it's close to 1, but 0.2 and 0.2 is nowhere closer to 1, because the correlation value should be, right, the correlated value should be somewhat closer to 1, okay, or it should be closer to -1. So since it is not closer to 1, less than 0.5, these two variables are not helpful in terms of predicting our housing price. So with this itself, we can make out which features are required or helpful in terms of predicting my housing price. So size and UDS, we can include only this one. But what I did, I just included all the features, okay, independent features. And then I created two variables, x and y. X is holding all the independent variables. Y is holding only the dependent variable. Next, what I do is I'm using the class linear regression to, and here I just initialized the class linear regression, which is available as part of a package called sklearn. This is the machine learning package. You need to remember that. And here, in this case, I initialize the class. The next line, what I did, I have created a meaningful name here, model, as a variable. On the right side of this, what I do is I just fitted this model. Fit, init fit is nothing but a linear regression class. In that, we have something called fit method. Here I have used the xtrain. Xtrain is nothing but, look here, this is the one test. There is something called train test split, using which we can split the data into 75-25 ratio. So here, with this, we have splitted the data xtrain and ytrain. And sorry, here we have trained our model. This is where we are training the model, linear regression model. So xtrain is nothing but this variable is holding all the 4 independent features, and this one is holding only the dependent variable, housing price. That too for training data set only. Okay, this model gets stored here. Using model.coef, we can find out the slope for each and every independent variable. The intercept you can find. As I told you, each independent variable has its own slope, whereas intercept is common. Okay, this is not, this is only one value will be there. Okay. Next one is, yes, we have trained the model, machine learning model, linear regression successfully. Now we need to apply the model on the unseen data, because we trained the model with the training data set only. Now we need to apply this on the unseen data. Now we can see that, yes, predicted values for the unseen data, it is given here. It's something like your manager gives you the data set, you trained your model, and now he gives you some new data, and he tells you, hey, can you give me a predicted value for this one, because I don't have any housing price now. Can you predict and tell me? Yes, we can say, sir, this is the predicted housing price for the given data set. Whatever the new data set you get, this is the price. Okay, this is how you can train your linear regression, and then you can predict the model. Okay, fine, guys. Since not many of them joined.